China's relentless march towards space supremacy gained further momentum on May 11, 2025, when the nation successfully launched 3 sophisticated Yaogan-40 Group 02 remote sensing satellites into a sun-synchronous orbit. The satellites were deployed via a Long March 6A rocket that lifted off from the Taiyuan Satellite Launch Center in the mountainous terrain of Shanxi Province at precisely 9:27 p.m. Beijing Time, 13:27 Universal Time Coordinated. This meticulously coordinated operation marked the 574th mission of China's storied Long March launch vehicle family and reinforced China's status as a spacefaring superpower with unparalleled launch cadence, technical maturity, and long-term vision. While the Chinese government maintains the official position that the satellites are dedicated to electromagnetic environment detection and scientific experiments, global defense analysts and aerospace experts have no doubt that the launch represents a significant enhancement to the People's Liberation Army's (PLA) space-based intelligence gathering infrastructure. The Yaogan satellite family, first introduced in 2006, has grown into one of the world's most robust and diverse Earth observation constellations. Each satellite group within the Yaogan series is typically tasked with a specific mission profile, ranging from high-resolution optical imagery, synthetic aperture radar, SAR, surveillance, and infrared mapping to electronic intelligence, ELINT, signals intelligence, SIGINT, and maritime domain awareness. In the case of Yaogan-40 Group 02, the configuration is strongly suspected to carry advanced ELINT payloads, which are instrumental in identifying and analyzing electronic emissions from radar installations, communication centers, air defense networks, and naval assets. These capabilities enable China to create detailed electronic order of battle, EOB, maps, essential for both peacetime strategic planning and real-time battlefield operations. With a constant stream of data from such satellites, Chinese military planners gain a comprehensive picture of global activity, enabling the PLA to track fleet movements, monitor adversary military exercises, and anticipate potential threats. The launch vehicle, the Long March 6A, represents a significant evolution in China's rocket development program. Compared to its predecessor, the Long March 6, the 6A features a more powerful core stage and 4 strap-on solid rocket boosters, making it the first Chinese rocket to incorporate this particular booster configuration. This design not only improves the rocket's lift capability to nearly 4,000 kilograms for sun-synchronous orbits, but also increases its flexibility in delivering multiple satellites to precise orbital slots. With a proven track record of reliability and pinpoint accuracy, the Long March 6A is quickly becoming one of the central pillars of China's satellite deployment strategy, particularly for constellation-building missions like Yaogan, which require carefully choreographed insertion to maintain network geometry and coverage consistency. Taiyuan Satellite Launch Center, which hosted the May 11th liftoff, plays an indispensable role in China's space ambitions. Nestled over 1,500 meters above sea level in a remote mountain valley, the launch facility is ideally located for missions targeting polar or sun-synchronous orbits, crucial for Earth observation platforms. Over the past decade, Taiyuan has seen dramatic upgrades in infrastructure, tracking capabilities, and launch complex safety systems, enabling it to handle a growing number of high-priority missions each year. The location's relative isolation provides excellent security and operational secrecy, key considerations when launching payloads suspected to have military applications. It is also one of the preferred launch sites for missions involving classified payloads, often with little to no public broadcast of liftoff footage or telemetry data. China's consistent stream of Yaogan satellite launches underscores a strategic shift in global intelligence architecture. With each new addition to the Yaogan fleet, China improves its ability to generate persistent, high-resolution, multi-spectrum coverage of terrestrial and maritime regions of interest. This is especially critical given Beijing's ambitions to project power far beyond its traditional periphery. The vast expanse of the Indo-Pacific, the contested waters of the South China Sea, the military choke points in the East China Sea, and the ongoing standoff scenarios in Taiwan all represent areas where near real-time satellite intelligence can drastically reshape the dynamics of escalation, deterrence, and strategic dominance. The Yaogan satellites form the orbital eyes and ears of this strategy, silent, persistent, and increasingly omnipresent. In addition to geopolitical and military dimensions, Satellites like Yaogan-40 Group 02 offer valuable contributions to civilian sectors. By gathering electromagnetic and environmental data, the satellites can help monitor atmospheric radiation, track interference sources that might affect telecommunications, and provide insights into space, whether that may impact satellite or aviation operations. Moreover, their sensors could potentially be used for early detection of seismic activity, contributing to disaster preparedness and civil protection systems. China often highlights these dual-use functions in official communications to emphasize the peaceful aspects of its space program. Yet, the true breadth of the satellite constellation's potential is apparent to anyone familiar with modern reconnaissance doctrine. These assets are as much tools of military superiority as they are instruments of scientific discovery. China's space policy is deeply intertwined with the doctrine of civil-military fusion, a national strategy that mandates the integration of civilian technological advancements into military applications and vice versa. As a result, there is little separation between China's Civil Space Agency, the China National Space Administration, CNSA, and its military space branch under the Strategic Support Force, SSF. The same companies, such as China Aerospace Science and Technology Corporation, CSC, and China Aerospace Science and Industry Corporation, CASIC, that build and launch planetary exploration spacecraft are also responsible for the development of reconnaissance satellites and missile early warning systems. The launch of the Yaogan-40 Group 02 satellites is thus part of a much larger continuum of missions, all aligned under a centralized strategic vision of technological self-reliance, battlefield digitization, and space domain dominance. The timing of this launch is also significant. It comes amid rising tensions in the Asia-Pacific region and increasing rhetoric over contested territories. It coincides with other key developments in China's space program, including the continued expansion of the Tiangong space station, planning for a permanent base on the Moon as part of the International Lunar Research Station, ILRS, project, and the upcoming sample return missions from both lunar and Martian surfaces. Each of these endeavors represents a different facet of the same overarching strategy: to cement China's status as a comprehensive space power that is not only capable of Earth observation and satellite-based communication, but is also actively shaping the next generation of space governance, exploration, and industrialization. From a global perspective, China's ability to successfully conduct high-frequency, precision satellite launches without international assistance is reshaping the strategic calculus of other major space powers. The United States, for example, has accelerated the development of its own military constellations, including the next-gen OPIR, overhead persistent infrared, missile warning satellites, and proliferated LEO constellations under the Space Development Agency, SDA. Similarly, India is expanding its RISAT and Cartosat series. Japan is investing in its quasi-zenith satellite system, QZSS, for regional positioning and surveillance, and the European Union is enhancing Copernicus and Galileo programs for Earth observation and navigation. These parallel developments reflect the growing recognition that space superiority is now foundational to terrestrial security and economic resilience. In the broader context of China's space timeline, the May 11th launch of the Yaogan-40 Group 02 satellites will likely be remembered as one of many stepping stones that collectively transform China's space infrastructure into a force multiplier across all domains of national power. The mission adds not only to the quantity, but also to the quality and sophistication of China's on-orbit capabilities. As the nation continues to build toward a unified, all-domain command and control ecosystem that integrates space, cyber, electronic warfare, and traditional military operations, satellites like those launched on May 11th are becoming the digital backbone of a fully networked battlefield of the future. In conclusion, the successful launch of the Yaogan-40 Group 02 satellites aboard a Long March 6A rocket on May 11, 2025, is not simply a matter of adding 3 more satellites to Earth orbit. It represents the manifestation of a deliberate, long-term strategy to dominate the high ground of space through technological innovation, industrial scale, and military foresight. It sends a clear message to the international community that China's space ambitions are no longer aspirational. They are operational, and they are accelerating. With this mission, Beijing has once again demonstrated that its reach into the heavens is matched by an increasingly detailed and strategic view of the Earth below. The skies may be silent, but the implications echo loudly across geopolitical fault lines and into the future of global security.